Assalamualaikum warahmatullahi wabarakatuh. In this presentation video, our group, consisting of Irshad, Izzat Fahmi, Hamizi, and me, Ziyad Ishraf, will present to you about the microprocessor mini project that we've been working on. For the brief introduction, microprocessor is a compact and integrated circuit that serves as the brain of a computer or any electronic device. This mini project serves as an exploration into the usage and the application of the 68K microprocessor. It is aimed to provide a comprehensive understanding of its capabilities and the practical implementations of microprocessor. And in this project, we will dive into further understanding the process of microprocessor system by carrying out two distinctive tasks given by our lecturer. For the brief introduction of task A, it is the development of a system where pressing one switch will result in lighting up each LED and pressing another switch will turn off all the LEDs. It is made by designing the control logic and then coding the assembly program using the IDE 68K software. The result that we obtain shows that the LEDs lit up in a sequence when the successful operation of system in task A. For the brief explanation of task B, we created a microprocessor system-based traffic light control that is designed for controlling the pedestrian phase and the handling of emergency conditions. This system utilizes digital input and output ports. For two inputs, there are two buttons, that is, the pedestrian buttons, which will activate the interrupt-driven routines, and the emergency button. Whereas for the outputs, it will handle using the GPIO pins, specifically to control the green light, red light signals. The results that were observed indicated that the developed system could promptly respond to the input triggers and switch the output to facilitate proper traffic management and safety, especially for pedestrians. The objectives that we aim to gain from this mini project is to further enhance the application of a microprocessor-based system using the MC68000 model. Secondly, students will also be able to design and implement the knowledge learned in theoretical classes and stimulate the system. With this mini project, it will provide students with more hands-on learning experiences based on real-world applications, helping them to better understand the concept required in application of microprocessors. The scope that was done in this project is simulating the design system using the IDE 68K software. Secondly, designing the logic for controlling LEDs using switches. Third, creating flowcharts to show the operational flow of the system design for better understanding. Fourth, designing microprocessor systems with specific inputs and outputs. And the fifth one, it is to programming the microprocessor to handle interrupts from I/O ports and control traffic lights via GPIO outputs. Diving into the project background, what is a microprocessor? A microprocessor implements a computer in the computer. Microprocessors are used to follow orders and their advanced calculations to achieve any kind of activities. Microprocessors also varies from simple calculations to high-level reasoning. These days, microprocessors are really small but quite powerful despite their size. It is built into computers, smartphones, and any other electronic gadgets in the embedded system. There is also a CPU that explains its role by saying that it executes the commands which are contained in programs to the executions of commands. These are one of the main comparisons that we can point out from microprocessor and microcontroller. For a microprocessor, it is a central processing unit, CPU, on a single integrated circuit and is primarily focused to execute instructions and processing data. However, A microcontroller is described as an integrated circuit that have a CPU, memory, inputs and output ports, timer, and communication ports all embedded in a single compact chip. The general purposes for microprocessor is to computing tasks such as in computers, smartphones, and servers, whereas in a microcontroller, it is mostly used for embedded systems and specific control tasks such as in home appliances, automotive systems, and IoT devices. In a microprocessor, only the CPU requires external components like RAM, ROM, and I/O ports for full functionality, whereas for microcontroller, it includes the CPU, RAM, ROM, or flash memory, input and output ports. Sometimes they include ADCs, that is, analog to digital converters, and DACs, which is digital to analog converters on the same chip. For the IDE 68K emulator, it is the utility for emulation of the well-known in the 1980s to 1990s microprocessor Motorola 68000. It is applied in many computers, game machines, and industrial facilities. This emulator allows the 68K assembly language to be implemented. Other than that, users are also able to write basic code that interacts with microprocessor, which can only be done through hardware. This emulator comes equipped with necessary debugging features such as step-through and memory view that allow users to fine-tune their programs. This will make it much more easier for students who are still learning in microprocessor. And lastly, it emulates the 68K instruction set so that programmers will get a real view of how the code functions on an actual 68000 system.
So, I'm gonna explain about project operation. There have two tasks, which is task A and task B. For task A, all LEDs are off. The system starts with no LED lit. When the switch 1 activation, which is LED light series, the sequential lighting, when switch 1 is pressed, LEDs light up one by one, which means LED 1 to LED 2 until LED 8. Looping. After LED 8, the sequence restart from LED 1, creating a continuous loop. Switch 2 activation. Turn off all LEDs. Immediate shutdown. Pressing switch 2 turn off all LEDs, stopping the sequence from switch 1 and resetting the system. Ongoing monitoring. Constant check. Continuously monitor both switches to ensure the system responds to their status changes appropriately. For the final status, active monitoring. The system remains in this state, monitoring switches and adjusting LEDs until further instructions are provided or the system is turned off. For the task B, in the start state, all LEDs are off. In the system setup, D0 as a general purpose register, D1 pedestrian button mask, D2 emergency, D3 green light, D4 red light. Normal operation. Green light turns on the green light LED and stays on for a delay. Switch check. Monitor switches for pedestrian or emergency mode. For the pedestrian mode, red light turns on the red light for pedestrian crossing. Delay. Waits for a set time, then return to normal operation. Emergency mode. Red light. Keep the red light LED on until an emergency is clear. Delay routine. Provide a simple time delay to manage the light timing. Summary. When it's normal day, green light on. System check for switches. In the pedestrian, red light on for crossing and then back to normal in the setup of time. When the emergency, red light remain until the condition is solved. There are two flowcharts that we made in this task, which is task A and task B. In task A, first, the start condition. Then it will initialize register AO and D1. After that, it will read switch state into D0. Then it will read until it switch 0 on. If the condition is yes, it will load and update LED and it will end of code table. If it yes, it will reset AO to start. Okay, back. Is switch 0 on? If no, it will go as if switch 1 is on. If no, it will loop back to main and end. If yes, it will turn off all LEDs. But in task B, it will first thing first, it will start and then it will initialize the analog meter. Then it will initialize LED at address 2700 to off. Then it will turn on green light at address 2700. And then it will call delay routine. Then it will read input from 2701. After that, it will ask, is pedestrian button pressed? If it say yes, it will turn on red light at 27,000. Then it will return to normal operation and it will implement delay routine. And then it will end. If the pedestrian button say no, it will ask if the emergency button press. If no, it will return to normal operation back. And then if yes, it will turn on red light until the solution is clear.
This is the result for task A. In normal condition, all LED will turn off, and when switch 0 is turned on, LED 0 is turned on, like figure 4.1.1. After that, the next LED will turn on like in figure 4.1.2. For figure 4.13 and 4.14, LED 2 and LED 3 is turned on in sequence. For this, the LED 4 and LED 5 is turned on like the before. After that, LED 6 and LED 7 will be turned on. In the end, when switch 1 is activated, all LED will be turned off. In this task A, we replace switch 1 and 2 with switch 0 and 1, and we change the LED to turn on from the right to the left.
Next, move to the result and discussion of part B. The first one, figure 4.2.1, there's no switch on, but LED 0 is on. It means the green light is on and the system is operating in normal condition. The second one, figure 4.2.2, switch 1 is on and also LED 1 is on. The system is operating in emergency mode, which means the red light is on. Figure 4.2.3, switch 0 on, LED 1 on, which is mean the system is in pedestrian mode. Discussion for part B. The microprocessor-based traffic light control system was developed to efficiently manage pedestrian crossings and emergency situations. The system utilized two input buttons, a pedestrian button that activates and interrupts driver routine for safe crossing, and an emergency button that quickly adjusts the traffic lights. Output for green and red lights are controlled through GPIO pins, enabling the system to respond promptly to input triggers and ensure proper traffic management and safety. LED 0 is on in normal condition as it functions for green light. When switch 0 and 1 activate, LED 1 will change to red light so the cars will stop or give emergency car to pass. Switch 0 act as pedestrian button and switch 1 act as emergency vehicle to pass.
In a nutshell, students have enhanced the application of a microprocessor-based system using the MC68K model allows students to design and implement their theoretical knowledge, simulating real-world system. This approach provides hands-on learning experience, deepening their understanding of microprocessor concept and better preparing them for practical application. Both tasks required a student a full knowledge of microprocessor, which is used to use software, write coding and structure the coding.
And that's all from us. Thank you for watching.